Once you have watched all of the videos on naming, that would be the 2 videos on ionic compounds, there's one on covalent, one on hydrates, and the other one on the stock method and acids. Once you've seen all those videos, what I would encourage you to do is challenge yourself and see how you do when all of these different things are mixed up. This is going to be so important because this is how things are in reality when you're working with chemicals or you're working with chemistry. And as we move on in the course, you've got to be able to speak and write the language of chemistry. So what I've done is I've put together 2 tutorials for you. The first one, I'm going to give you a lot of different names, and we are going to one by one go through these, and we're going to write the chemical formulas. And the second one, I'll give you the formula and we will write the names. So I'm just going to walk you through the thought process. Now what I want you to understand is the more you do this, the better you will get. And you will get better very, very quickly if you're putting your time into it. So number 1 says sulfur. And what I know about that is sulfur is just simply an element on the periodic table, and it's just a symbol S. That's it. Number 2 is sulfide. Now, when any of the non-metals, except for the noble gases, when any of these non-metals to this upper right side of the stair-step line become anions, that means they've stolen electrons, then we change the ending of the name to IDE. So sulfide is still the symbol S, but it's in that -2 column. So this is going to be S minus 2. That is just the anion of sulfur. Now, number 3 is sulfate. If you have memorized these polyatomic ions, and I've got a list of them right here, I would encourage you to have these in front of you if you don't know them really well. We know that sulfate is simply a polyatomic ion, and the formula is SO4 minus 2. Likewise, sulfite is also a polyatomic ion. It's right here. That is, let me push that up so you can see it. It's right here. That is SO3, 2 negative, or -2. Now, you can see I put these together because to the untrained eye or someone who has not had chemistry, these almost look like the same thing. The endings are just a little different, but you can see that those endings are very important. Let's look at number 5, sulfur trioxide. Now I'm going to tell you what catches my attention first thing. I see this prefix. I also see that there are 2 nonmetals. That tells me that this is a covalent compound. And because it's a covalent compound, I do not crisscross. I just take note of the fact that there is 1 sulfur and there are 3 oxygens. And I'm just going to write that formula. These prefixes are now becoming my subscripts. So it's SO3. Now the reason that one is important and the reason I put these close together was I want you to see that subtle difference. A lot of students may get upset if they miss a question asking about a polyatomic ion because they left off the charge. And what you can see is that charge is really important. These are 2 totally different things. When I see SO3 with the -2 charge, I know that that is the polyatomic ion, sulfite. But when I just see sulfur trioxide, I know that's a covalent compound and there's not going to be a charge with that. And number 6, sulfur tetraoxide. Again, that prefix just really caught my attention, but the fact that it's 2 nonmetals makes it a covalent compound. So I'm going to put a little C out here to the side for covalent, and I know that there is 1 sulfur and 4 oxygens. So likewise, I'm going to write 1 sulfur and 4 oxygens. And if you'll remember, for covalents, we like to say that our prefix becomes our subscript, keeping in mind that if there's only 1 of the first element, like here, we don't use mono. If there's 1 of the second one, we do use mono. Number 7 is sodium oxide. This is a metal and a nonmetal. That makes this a binary ionic compound. And all I'm going to do is I'm going to write sodium with a charge of +1 and oxygen or oxide with a charge of -2. Just as a little friendly reminder, I knew that sodium had a +1 charge because it's in the +1 column of the periodic table. Oxygen has a -2 charge because it's in the -2 column of the periodic table. So when you identify it as ionic, the next thing I want you to think about is write the ions. The first 3 letters of the word ionic are I-O-N. So ionic, write the ions, and anytime we write the ions, the next step is going to be crisscross. So that is Na2O. And remember, in the background, what Mother Nature is actually doing here is she is putting these together in the smallest whole number ratio possible so that the charges balance out and you have an overall neutral charge. Number 8 says fluorine gas. Now this is one that I ask my students to memorize. I call them the special 7. It's 7 of your very common diatomic molecules. I'll show you where those are real quick just in case you've never seen that. I've got a little trick for remembering these. So there's 7 of these. Knowing that, if you'll start right here at the number 7 and draw a 7. Go to 7 and draw a 7. N2, O2, F2, Cl2, Br2, I2, and you do need to invite hydrogen to the party, H2. These particular elements cannot exist alone, so they're always going to be bonded to their clone, if you want to think of it that way. And when you see H2, that's hydrogen gas. When you see N2, nitrogen gas. O2 is oxygen gas. F2 is fluorine gas, and so on and so forth. But that's the little trick I have for you today. Go to 7, right here, draw a 7, invite hydrogen, and those are the 7 diatomic molecules that most beginning chemistry students should know. So when I see fluorine gas, I know that is simply fluorine bonded to itself. That's actually what we call a purely covalent or nonpolar covalent bond, and it means that both of those fluorines are sharing electrons completely equally. It's kind of like a perfectly equal tug of war. All right, let's look at number 9, magnesium. Magnesium is just an element right on the periodic table. It is just a plain old metal, so Mg. Number 10 says magnesium ion. Now this little word right here tells you it's not just neutral magnesium anymore. What's happened is that magnesium has lost some electrons. And so what you can do is you can look at the periodic table and you know magnesium's in column 2. So we know it's going to lose 2 electrons and it's going to have a +2 charge. So the cation of magnesium is Mg+2, which is the magnesium ion. And we learned how to do these when we talked about writing and naming cations and anions. Permanganate, I recognize that as one of the polyatomic ions that I have memorized. Right here it is, MnO4, -1. If you are finding yourself still having to consult that list a lot, do yourself a favor and memorize those polyatomic ions. It is so worth your time and will make your life just a gobs easier. All right, let's take a look at number 12. Iron, then I have the Roman numeral 3, chloride. Well, this is a metal, non-metal, so I know it's ionic. But this is a transition metal. That means that it is located in this middle section of the periodic table. And because of that, they had to tell me the charge of the metal because iron can have a variety of charges. So what this is telling me is that iron is a +3. Anytime you see the Roman numerals, that is the charge of the metal always, because you'll always know the charge of the non-metal. So iron has a +3 charge and chlorine has a -1 charge. Remember, if it's ionic, think ions, write the ions, crisscross them, and you get FeCl2. And I'm going to mark that one as ionic. And notice now that I've done a few of these, if it's a covalent compound, you'll notice there's no crisscross. We don't need to do that. They're telling us what the subscripts are right in the name. We only need to crisscross when we are dealing with ionic compounds. Number 13 is hydrobromic acid. And I know if it's an acid, it's going to have an H in the front, the hydronium ion, which has a +1 charge. This looks to be a binary acid to me. This means this is hydronium crisscrossed with bromide. Bromide has a -1 charge. Another way I knew this was binary is because it had hydro in the front, and we don't use hydro in the front if it's got a polyatomic ion in it. So the ones cancel, or you could crisscross, same thing, and you get HBr. And the last one, calcium hydroxide. That's ionic because I have a metal and a polyatomic ion. By the way, acids, that's an acid, but we do crisscross it just like an ionic. Calcium has a +2. Hydroxide is OH -1. Now what you have to take into consideration here is the fact that's a polyatomic ion. So before you bring this 2 down, you want to wrap that polyatomic ion in parentheses. Remember the 3 P's, protect the polyatomic with parentheses. So the correct way to write this is CaOH2 on the outside. The incorrect way, which I see a lot teaching beginning students, would be this. And so you might want to jot that down and then just draw a line through it. This is wrong because you did not have the parentheses. And this would cause you trouble later if you were doing a problem where perhaps you needed a mole-to-mole ratio or you needed a molar mass so that you could go from grams to moles, or maybe you're trying to balance an equation. This can cause a lot of problems down the road, so you want to be really careful with that. So we've got a few more of these to do. So let's take a look at this next set. Number 15 says lead 2 phosphate. I noticed 2 things here. I know it's ionic because it's a metal and a polyatomic ion. I also see they're using the stock method to tell me the charge of the lead. Otherwise, I wouldn't know which one it was. So they're saying, hey, that lead's a +2. So lead is Pb +2. We know that phosphate is PO4 -3. We're going to crisscross. We're going to protect that polyatomic ion with parentheses. So it's going to be Pb3 parentheses PO42. So again, crisscross. How do we know to crisscross? Simply because it was ionic. Number 16 is argon gas. Now, a lot of times, because I just taught you this, you hear gas and you think, oh, maybe that's Ar2. But what I want you to notice is that argon is a noble gas. It's not one of these special 7 diatomics. These guys won't even bond with themselves. So argon gas, argon is a gas at room temperature. Argon gas is just Ar. There's not a 2 because it is not a diatomic molecule. Number 17, Tetra phosphorus octoxide. Right away, most of you probably saw these prefixes. That's kind of a dead giveaway. The reason that it's covalent is you have 2 nonmetals technically. But when you see this, you're like, okay, that's 4 phosphoruses, that is 8 oxygens. Basically, they just gave you the subscripts. So P4O8. That's it. That's a covalent compound. Again, notice no crisscross. Number 18 is potassium sulfate hexahydrate. We just recently learned these in the hydrate lesson. And what we learned was when we're writing a hydrate, we write the ionic compound first, big fat dot, and then we put the correct number of waters after that dot. So potassium sulfate is just an ionic compound. And to save some space over here, I know potassium has a +1. I know sulfate is SO4 -2. So I'm going to crisscross those. That gives me K2SO4. So there's the ionic part of the formula, big dot. And then according to this, we have 6 water molecules loosely attached to every one of those potassium sulfates. So we just simply write 6H2O. So anytime you see hydrate at the end, you know you're going to have the dot and then the appropriate number of waters at the end. This end will always be the ionic compound or the salt. Just be careful there because sometimes they will give you some transition metals and you're going to have to pay attention to the Roman numerals. Number 19 is sulfuric acid. And a couple things I noticed. Since it's acid, I know I'm crisscrossing something with hydronium. So I'm going to go ahead and write that down. Now there's no hydro in front of this. That ic probably came from 8. So it was probably the sulfate polyatomic ion, which is SO4 minus 2. How did I know that? I've memorized it. Crisscross H2 SO4. Again, I noticed it was an acid, but there was no hydro in front. That was a big clue for me. This probably came from a polyatomic ion. And remember, when we're naming acids, 8 turns into ic and ite turns into us for that polyatomic portion of the name. Number 20, beryllium hydrogen carbonate. That is ionic. I know it's ionic because I see a metal, and then hydrogen carbonate is actually a polyatomic ion. That one is often confusing for students because they see 2 words, and most of our polyatomic ions are just 1 word. But if you look right here, hydrogen carbonate is HCO3 minus 1. So I am crisscrossing beryllium, which is in column 2 of the periodic table, so it has a +2 charge, with hydrogen carbonate, which is HCO3 negative 1. So we're going to crisscross, and we're going to get BeHCO3 2. All right, number 21, bromide. That is the anion of bromine. It's in the -1 column, Br minus 1. Bromate is a polyatomic ion that I have memorized, BrO3 minus 1. Bromine is just an element off of the periodic table. So again, you know I like to put these together because I like you to see those subtle differences. Bromine turns into bromide when it steals 1 electron. Bromate is totally different. It is just a polyatomic ion that we have memorized. All right, number 24, disilicon pentasulfide. So again, what catches my attention here is I have prefixes, so I know it's covalent, but what technically makes it covalent is it's a nonmetal. I have 2 silicones and 5 sulfurs, so Si2S5. Looks kind of odd, but these can be a little bit of a tongue twister, but you can see they're so easy. You really don't have to do anything except recognize what the prefix stands for. Number 25 is silver chloride. That is ionic. That means I'm going to crisscross the ions. Silver is a +1. Chloride is Cl minus 1. The ones cancel, and you get AgCl. Number 26, I see I have a hydrate. So I know the first part of this name is going to be an ionic compound, and the second part is going to notate that I have 10 waters, and that comes from that deca. There's going to be a fat dot in the middle. So they're telling me right here this is cobalt 2. I know that hydroxide is OH minus 1. So I'm going to crisscross those, and that's going to give me CO, OH, 2, dot, 10, H2O. That's it. Okay, got just a couple more. Nitrous acid. So I know that us comes from ite. I know there's no hydro in the front, so that tells me this probably came from a polyatomic ion. And the polyatomic ion nitrite is NO2 minus 1. Ite turned into us. So I'm going to crisscross hydronium with NO2 minus 1. The ones cancel, HNO2. And we are almost done. We only have 2 more to go. Barium dichromate, this is ionic because it is a metal and a polyatomic ion. Barium is in the second column of the periodic table, so it has a +2 charge. Dichromate is Cr2O7 -2. The 2's cancel each other out, so you just smack them together and you get BaCr2O7. And very last one, manganese 2 thiocyanate. That would probably look really scary to someone who didn't know the basic rules, but you know that that 2 is just giving you the charge of the manganese, really saving you some time there. You know that the formula for thiocyanate is SCN -1. And because it's ionic, you know you're going to crisscross those. So the answer is MnSCN2. So that was a great mixed review. That covers everything. Elements, anions, cations, ionic, covalent, stock method, acids, and hydrates. That's most of what you're going to see in a general chemistry course. For the next tutorial, I will actually give you formulas and we will practice going to names. If you keep doing these naming drills over and over, you'll get better very quickly.